Okay, so we did in the contents pane, we remove everything. When the tool is finished running, a city feature class that contains those features have selected plus the visible fields we selected is added to the Los Angeles River Park site geodatabase. So a corresponding layer is added to the map in the corresponding system we have chosen for this project. And in the contents pane, that we will remove the old city polygon layer. So I haven't exported yet because I didn't select anything. So I'm gonna do is select by attributes, city, new selection, and I'm gonna add a class. So the state, I think name just equal to Los Angeles then. That will be a lot of attributes. So I'm gonna scroll down to with the L. So it will be Los Angeles, Los Angeles. There. Click add and I'm gonna run. So once we have it selected, then we're gonna go. We see Los Angeles is selected and that's our city. Then we're gonna do is right click on here. Remember that's what we're gonna do. In the contents pane, we'll right click the city polygon layer and click data, and then we will do export features. Once we export a feature that we have a city, this option displays the same copy feature tool in the geoprocessing pane that we worked with here earlier, and in the output feature class. The parameter of the copy feature tool, we will highlight and delete the entire path and we will just type cities. So putting our database. So we do not have a city. So put cities and click save. So once we have the cities, we compare the tool and what I have here and click run. So when the tool is finished running, a city feature class that contains just those features we have selected plus the visible fields we selected is added to the LAR Los Angeles River Park site geodatabase. A corresponding layer is added to the map in the coordinate system we have chosen for the project. And here, now we're going to right click on this and remove this old layer and open the attribute table of the new cities layer to verify that the export worked as expected. So, let's see, right click on it, open attribute table. So I do have Los Angeles and we can see from here. So it is Los Angeles city file. And the table contains the two attribute that we kept, so which is name and shape. We have a shape and area and everything. So it has a lot of Los Angeles data. So let's see if I want to keep just Los Angeles or everything close here. And open the attribute table of the new cities layer to verify that export worked as expected. The table contains the two attributes we kept, plus the software managed attributes. I don't want that many attributes, I just want Los Angeles. So close the table and many other open table or panel under or top of the map view. So I'm gonna close it out. And if necessary, the project can expand the Los Angeles River. So I don't have it now. I'm gonna go back to our view and our catalog pane. So now under here, I do have the river copy features. So Parkside GeoDatabase, now it should contain 4 feature classes. So we have a block Centroid projects and cities. We have a cities and park regional, which is right here, and along with the 3 bright layers and the Los Angeles. So the line 1, polygon 1, and polygon 2, and the Los Angeles perennial table. Now we're going to save everything, and we will start with a new exercises now. So now the other workflow that we're gonna do is go back to map and we can get a new map. So for the new map, in row 5 of the data requirement table, we made a note to dissolve the Los Angeles river dataset. This action will combine the river's 265 individual line segments into a one-line feature, simplifying the task of creating buffer around the river here. So Dissolve 2 creates a new feature class. When we run the tool, we will convert the Los Angeles River shapefile and into a geodatabase feature class as a part of the operation. So now we will dissolve the river. So a very common way for geoprocessing tools, including dissolve, can be accessed from the gallery on the analysis tab. So if necessary, we start the pro that we have everything here. We will copy the lesson 4C. I have it here, and just I'm gonna copy and then just paste it here, and I'm gonna rename it, change the C1 to D. And now, so we will have to open it up, close everything, okay, then double click. So we have the lesson 4D open, and on the analysis tab we'll expand the gallery by clicking so analysis here, and the dissolve tool, dissolve linear, where's dissolve, right here, dissolve. So we drop down and you just look around, and the tool gallery provides quick access to some of the most commonly used tools among the hundreds, including with ArcGIS. So dissolve tool, and we scroll down. Then we find this tool in the Manage Data group and click the tool to open it. For the input feature parameter, we will browse for the Los Angeles River, which is, I didn't add it here. So Los Angeles River, it will be in my folder and here in Parkside, and it will be geodatabase, hydro, and river. City of Los Angeles River. So City of Los Angeles. So City of Los Angeles. So not in the geodatabase. City of Los Angeles right here. And Los Angeles River. And once we have a Los Angeles River, we will change the output feature class name from Los Angeles River dissolve to Los Angeles River. So river shapefile and dissolve, which is cool. I think dissolve is fine. I just want to leave it. And here we will have a name. And so we will change the output feature class name from Los Angeles River dissolve to Los Angeles River. Outputs of tools default to the project home geodatabase. We will notice that the entire path to the geodatabase will be displayed when we hover on the pointer. So it's the correct geodatabase path, so that I'm gonna save it there. It will be displayed when we hover the pointer over the text box. So however, we only need to change the name of the new feature class, the last part of the path, and then in the dissolve fields, click to name, select the name, and then click the checkbox. So checkbox, so that we have create multiple features, create multi-part features. So selecting this checkbox preserve the name field, which we want to keep in the output attribute table. It also affects the way the tool works. So instead of creating a single output feature, ArcGIS Pro will create a single feature for each unique value in the checked field. In this case, it results in the same thing because the field name has only one value, Los Angeles River. If we selected a different field, however, the output feature class would have more than one feature. Okay, when the tool is finished running, so I have to click Run, and a feature class is added to the project geodatabase, and a layer is added to the map, which is right here. And open the attribute table of the Los Angeles River. Note that the dissolve tool took the shapefile with 265 features down to one record. So let me, there. So it's just one record, and it just put everything. Let's put the I want to put Los Angeles River back so we can see the original data. Los Angeles River, it had a 265 records. So except for name field, we selected the attributes from the origin table have been dropped from the one remaining record. Confirm that the length values match. So we can do the length and we will say statistics. Then we can do the sum. Let's see if I can see the sum. We have the mean. I don't have to see those. Gonna do the sum property. Statistics. I have to sum it. Well, can I do? Yeah, I don't think length statistics. So length statistics. It didn't give me a total now. That's how the ArcMap. When you do statistics, you get everything. You can do calculate field now. Summarize. So yeah, summarize statistics. So you still have to do. If I do name, I don't know field. It will be length, and I can do a sum here. Click run. It should be the same. Open. See, it's the same with this one, dissolve. Yep. Oh, a little difference, but it's very close. So it depends how they sum it. 95, 95, 7, 3, 4, 166,495, 166,495. See, they're very similar. It depends how they round up. And I got the correct answer. So here for the name field, we selected the attributes from the original table and have been dropped for the one remaining record. Confirm that the length values match. So I did it. That we will learn more about the solve tool, and we're going to prepare the park data. The park regional feature class is already in the project geodatabase, but we still have the preparation task of loading data into it. So that's because this data set is missing the two park features that we saw in the new park shapefile. And close everything out so we can see our map and move things around. So next we will do is add the data to the map. The park regional feature class is already in the project geodatabase, but we still have the preparation task of loading data into it. That is because this dataset is missing the two park features that we saw in the new park shapefile. We will add the data to the map. So now we can remind ourselves within two parks we were talking about. Now we can make a copy for this, and I think I'm not gonna make a copy, so I just renamed this lesson 4 and E. Lesson 4E, and then I'm gonna do is lesson 4E. I already have it. And now we will do is we open it up. Open it up, and then we will make a copy. And from the project geodatabase, and then I have here is that under the resource data expand, I'm gonna expand here. I'm gonna expand here. I'm gonna from the row of the geodatabase. So add parks regional to the map optionally symbolize the layer in a shade of green. So, and I don't have anything. I'm gonna add my river. So just give me 1 second. I'm gonna add the city. Yeah, I need the city and I need the county. City, county, did I have a park yet? New park. I don't have the new park. So parks regional. Yeah, we did park regional. And then we have a new parks. Did we have a new parks? No, not yet. I think we are going to do it now. Los Angeles River. Los Angeles River dissolve, which is right here. Okay, I have everything here. Let's see. The river is a little weird. The county line. So city, where is city? City, I cannot see the city. So I'm gonna move on top. So this is city. That's why we get cut off here. So now we get to see everything. We have to work on the park data, which we have to add the data. So from the project that we add Parks Regional to the map, optionally symbolize the layer as a shade of green. So parks, I'm going to do is shade of green. That we have a green. Under source data, we will expand park data folder and add a new park shape file. New park shape file, which is park data, new park shape file, and add it here. Now we have our new park, so I'm gonna make a different color so that we can see our park. Click apply. So, and then, oh no. So I'm gonna zoom to layer. Okay, so it's really tiny that we can barely see our new park here. And we zoom to here and we add this in parks data. So we have here and we will compare the attributes. So we compare the attributes. We want to get these two new parks features along with their attributes into the park feature class. We face a complication is that the data sets have a different attributes. So we open the park regional attribute table. So it has 1,229 records. It's user managed attributes as name, type, and acres. So now I'm gonna open attribute table first, and that we see everything. Yep, hours. We don't have acres. This is new park, not new park. So it's the park regional. Yeah, which is 1,209. Attribute we have name, type, and acres. The type attributes, so the type attributes is right here, describes whether the park is a local, state, or national park. We open the new park attribute table, so which is right here. So the new park attribute table, its user managed attributes are name, category, addresses, and telephone. We even have a telephone and hours. Both tables have a name field, and category is similar to the type field in the parks regional table in that it identifies the parks as state parks. The other fields do not have equivalents in the parks regional table, and we will close the attribute table. And then we will append to load data. So for append to load data, we're going to do is that we will do everything and we will talk about the dissolve. That's fine. Okay. So use append to load data. So the append tool loads data from one or more data sets and appends the feature into an existing data set. So it also provides tools for dealing with attribute mismatches. So on the analysis tab, find the append tool. So I'm gonna spend some time for the geoprocessing tool at once. So now I'm just gonna skip it for dissolving tool and then for some attribute. We just talk about the geoprocessing. I know it's a lot, but I will make up for some theory and back on for the videos. So on the analysis tab that we have the append tool. So gonna close everything out first and gonna go back here and append should be somewhere here and right here. So append, I'm gonna open it up and it's right next to the dissolve tool. For input dataset, we will click new parks. So I'm gonna go to new parks. And this dataset is the one to be loaded. Note that we can append multiple datasets, but we will be using only one for here. For target datasets, so the target datasets, let's see, new park input feature. And for target datasets, target, it didn't say target, and we will click output, input, and it didn't say. Oh, this is buffer, sorry. Append right here. So input that we have is new parks, and for target dataset, that target, we will click parks and regional, and the one is which will be loaded, and change schema type to use the field map to reconcile schema differences. Schema type to use the field map to reconcile schema differences. So this schema type displays the field map parameter with additional options to describe how attribute values will be loaded from the input to the target dataset. So this is also referred to as mapping fields. And the output fields column on the left side lists the available attribute columns in the target dataset, and the source column, and on the right side, so which is right here. The right side will let you to pick which field we want from the input dataset. And the field name match ArcGISPro assumes that the field should be matched. So now we have a name. Name will come first, and new parks will be name. And in the column map table name in the output fields column, notice that name has a match because there is a field name, named name in the new parks shapefile. Next, we will map the category field from new park to the type field in parks. So type, it will be merge rule. So park type in the field. So in the list of fields, we will click type and add a new source, and then in the list of fields, we will click category, add a new source category. So merge rule first, that's fine. And at the bottom of the list, we will click add selected acreage, and where is add selected subtype? The bottom, we had a category. Oh, no. Name. All right. Add a source. Yeah, add selected. So the bottom is here. So then we have it. So let's see again. So when you choose this category, and then you have to add there. So, and if you don't want it, you close it out, which is really nice. So it will be loaded in the type field of Parks Regional. And there is no acres field by this or any other name in the new parks table, so there is no need to map this field. The address, telephone, and hours information in new parks won't be loaded because Parks Regional has no appropriate fields to accept the values. If these fields were necessary, we would have to add these fields to the target dataset before appending it. We will compare the two here, and we're going to run the tool, and we will review the results. So we will turn off the new park layer in the map, and notice that the two features have been added to the Parks Regional. Open the Parks Regional attribute table and confirm that the two new park records were added at the bottom of the table. We should now have a total. So parks, so now the total, it will be 2100. So let's move at the bottom. So I'm gonna scroll down so that this 2 is added, and we can see that the acres is null because we do not have it, but we have everything here. And we close the attribute table for more information, and we're going to see the field data types later here. We will learn about fields data type. And now we're going to make a spatial selection in the Parks Regional layer. It is not one of the preparation tasks to reduce the Parks data, but the spatial extent of this feature class is bigger than it needs to be. And getting rid of extra features may help speed up some analysis operations. So next, in next step, we're going to use select by location to get a copy of just those parks that are within 3 miles of the Los Angeles River. So select by location to get the copy of it. It's very nice. Select by location. And we zoom to the park regional layer. So I'm gonna close everything. I don't want to close everything out. I'm gonna just zoom to layer so that we can see the parks and parks regional. Okay, we don't need the new map. We're going to do is select by location because that select by location. If necessary, we click the parks regional in the input feature layer drop down list. This layer should already be selected for you if you selected the layer in the contents pane. So now instead of intersect, we are doing is within a distance. So within a distance, selecting feature that we will have Los Angeles River. So I will do Los Angeles River dissolve for sure. That we will have to do is 3 miles. So I'm gonna do miles first and then put 3. So it's a new selection. So in the relationship drop-down list, we click within a distance geodesic. And for the selecting feature parameters, we click Los Angeles River and use search distance parameter to define 3 miles as the distance and leave the selection type parameter as new selection. And the spatial query will select parks within 3 miles of the river. By using the geodesic option, ArcGIS Pro will use the shortest path on the surface of a global rather than the planar distance of the map projection, which is the shortest path in a 2D Cartesian plane. If any bit of a park is within the geodesic distance, the feature will be selected. So I'm going to repeat again. So the ArcGIS Pro will use the shortest path on the surface of a global rather than the planar distance of the map projection, which is the shortest path in a 2D Cartesian plane. So if any bit of a park is within the geodesic distance, the feature will be selected. All the unselected features will be well out of the area of interest. So I'm gonna run and compare to the figure, and we're gonna it's gonna highlight it. See, so you can see the parks that it's 3 miles within, and it's all highlighted. It's really neat. And then field data types, we are not going to talk about it right now. And on the map, the park feature within 3 miles of the river are selected. At the top of the contents, we click list by selection button. And list by selection button. So now I'm gonna go. Yeah. So we have a 169 out of 1,211 was good for this criteria. So look at the layer list and note how many parks were selected. Again, these are the parks that are within 3 miles of the Los Angeles River. Confirm that we have a 169 selected records, which is perfect. And we will switch by the list by drawing order tab. Okay, perfect. So see, okay, I don't see all the selected. Alright, so now we can do copy features. So now we will copy the selected parts in the parks regional layer to a new feature class named parks. So now we open the toolbox again, an analysis toolbox, which is right here, and we're going to copy the selected parks in the parks regional layer to a new feature class named parks. We will open the toolbox, clicking here, and bottom on the analysis tab, we will note the copy feature is somewhere here. Double click the copy feature as one of the favorites, and click copy feature to open the tool. If necessary, we'll search for it. For input feature, we will click parks regional. An output feature, so that I'm going to put out into our geodatabase that we will just name it parks. So I'm click save and then we can just run. And we will compare the tool when it's done. Parks is right here, and then we're gonna to open attribute table. So we only have a 169. So when the tool is finished running and parks is created in the project geodatabase and the layer is added to the map, under contents we will run off the parks regional layer and resymbolize the parks in any shade of the green and zoom to the park over. So I'm gonna turn this on and off so you can see on and off. Yeah, perfect. And I go back to map and deselect. So let me turn this on and off. Let me close everything else and then zoom out a little bit and on and off, on and off. So those parks are near this river. So we zoom to the park layer and open its attribute table. So our previously we already see that it's 169 records to match the parks we selected here. And now we close the table. And we don't need the parks regional feature class anymore, so we can just delete it. I could just remove it here or delete it in the geodatabase and make sure park regional, not parks, in highlighted in the project project pane window under the project geodatabase. We will right click on it and delete it, parks regional, and I'm gonna just delete it so we can save some. We don't need a lot of data. So the feature class is deleted from the project geodatabase and the corresponding layer is removed from the map. We will still have the original parkland data in the source data folder. We can recover from mistakes if we have to. If the parks regional layer is not removed from the map, automatically right click and click remove. So I already did that, and go to project and gonna save, and we will do prepare the block groups data in the next video.